Hello everyone, I'm neerajj from JSB section. Today we're going to discuss about recursive function in C language. Functions. A function is a self-contained block of code that performs a particular task. Once a function has been designed and packaged, it can be considered as a black box, that is, the inner details of operation and invisible to the rest of the program. All that the program knows about the function is what goes in and what comes out. Every C program can be designed using a collection of these black boxes. Classifications of functions. Functions are divided into two types, library functions and user-defined functions. Library functions, predefined functions, that is function that has already been written and compiled and linked together with our program at the time of linking used by the C system. Example printf, scanf, square root of, etc. User-defined functions, functions that are developed by the user at the time of writing a program. Main is a special type of user-defined function. Problems encountered in user-defined functions are not used. When a C program is coded utilizing only main function, the problems encountered are difficulty in debugging, difficulty in testing, difficulty in maintenance. When same operation or calculation is to be repeated, space and time is wasted by repeating the program statements wherever they are needed. Advantage of using user-defined functions. When a C program is divided into functional parts, that is designed by a combinations of user-defined functions and main function. Each part may be independently coded and later combined into a single unit. The subprograms or functions are easier to understand, easier to debug, and easier to test. Some more advantages of using user-defined functions are when same operation or calculation is to be repeated, it can be designed as a function and can be called and used whenever, which saves both time and space. A function may be used by many other programs. That is, a C program can build on what others have already done instead of starting over from scratch. Recursion. When a called function in turn calls another function, a process of chaining occurs. Recursion is a special case of this process when a function calls itself. Example: void main printf backslash n. This is an example of recursion. Main recursive function call. Factorial of a given number using recursion. Void main int number fact is equal to factorial of number. Printf backslash n factorial is percentage d number. Factorial n int n. In fact, if n double equals to 1, return 1, else fact is equal to n into factorial of n minus 1, return fact. The recursion continues until some condition is prevent it. The prevent infinite recursion if else statement or similar approach can be used when one branch makes the recursive call and other doesn't. Example: sum of natural numbers using recursion. In sum int of n, int main int number comma result. Printf enter a positive integer scanf percentile d ampersand number. Result is equal to sum of number. Printf sum is equal to percentile d result return 0. In sum int of n, if n not equals to 0, some function calls its return n plus sum n minus 1, else return 0. The output of the following function is enter a positive integer 3, sum is equal to 6. Initially, sum is called from the main function with a number passed as an array argument. Suppose the value of n inside sum is in 3 initially. During the next function call, 2 is passed to the sum function. This process continues until n is equal to 0. During the next function call, 2 is passed to the sum function. This process continues until n is equal to 0. When n is equal to 0, the if condition fails and the else part is executed, returning the sum of the integers ultimately to the main function. Advantages and disadvantages of recursion. Recursion makes program elegant, However, if performance is vital, use loops instead as a recursion is usually much slower. That being said, recursion is an important concept. It is frequently used in data structures and algorithms. For example, it is common to use recursion in problems such as tree traversal. To find factorial of a given number 5, void main int number is equal to 5, int number fact equal to 0, num fact equal to factorial 5, printf backslash n factorial is percentile d number fact. Factorial 5 in 10, in fact if 5 double equals to 1, return 1, else fact is equal to 5 into factorial of 5 minus 1. Return 120. Factorial of 5 is 120. The flowchart of recursion follows recursive function followed by statements followed by condition. Recursive function directly if the condition is true, and it again goes through recursive function. If the condition is false, the remaining statements are executed and the process is stopped. Flowchart showing recursion. Note: in order to prevent infinite recursive call, we need to define proper exit condition in a recursive function. There are two types of recursion: direct recursion and indirect recursion. Direct recursion function is said to be direct recursive if it calls itself directly. In this program, FIBO is a direct recursive function. This is because inside FIBO function there is a statement which calls FIBO function again directly. Indirect recursion. A function is said to be indirect recursive if it calls another function and this new function calls the first calling function again. This program, function 1 calls function 2 which is new function, but this new function 2 calls the first calling function function 1 again. This makes the above function an indirect recursive function. Factorial of 4. Int n, in fact, if 4 double equals to 1, return 1, else factorial is equal to 4 into factorial of 4 minus 1, return 24. Factorial of 4 is 20. Here, the number whose factorial is to be found is stored in the variable n. The recursive function factorial num calculates the factorial of the number. As factorial is n minus 1 factorial into n, factorial function calculates the factorial by recursively multiplying n with factorial of n minus 1. Finally, when n is equal to 0, it returns 1 because 0 factor equal to 1. We program to print Fibonacci numbers using recursion. Hash include stdio.h int fibo int number. If number equal to 1 and number equal to 2, return 1, else return fibo n minus 1 Fibonacci's number number 2. Int main int I comma n printf enter the required term scan of percentile d and %n printf first percentile d Fibonacci numbers for I equal to 1, I less than or equal to 1 and I plus plus printf percentile d Fibonacci I return 0. This program uses recursion to generate Fibonacci series. In a Fibonacci series, nth term can be obtained by adding n minus 1 and n minus 2 term mathematically. Here, the number of Fibonacci terms to be generated is taken from the user and stored in variable n. A for loop is used to loop through numbers to be generated, which is sent to the function Fibonacci series. This function is used to calculate and return Fibonacci series. Inside Fibo, if the number term is 1 or 2, it returns 1. This is because the first two terms of Fibonacci series are both 1. The printed values of 1, then the next term, number 3, is passed on to Fibo function since it's not 1 or 2. The next term is series. The series is calculated by taking Fibo n minus 1 plus n minus 2, where n is equal to 3. This calculates the last two terms in the Fibonacci series. This is equivalent to Fibo 2 plus Fibo 1, which returns in 1 plus 1 equal to 2. This recursive loop goes on finally printing the series as 1, comma 2, comma 3, comma 5, and so on. Output: enter the required term 7. First 7 Fibonacci numbers are 1, 1, 1, 2, 3, 4, 5, 8, and 6. Disadvantages of recursion. Recursion programs are generally slower than non-recursive programs because it needs to make a function call, so the program must save all its current state and retrieve them again later. This consumes more time, making recursive programs slower. Recursive programs require more memory to hold intermediate states in the stack. Non-recursive programs don't have any intermediate states, hence they don't require any extra memory. Factorial 3. Int n, in fact, if 3 double equals to 1, return 1, else factorial 3 star into factorial 3 minus 1, return 6. Factorial 2. Int n, in fact, if 2 double equals to 1, return 1, else fact equal to 2 into factorial of 2 minus 1, return 2. The factorial of 2 is 2. Factorial of 1, int n, in fact, if 1 is equal to 1, return 1 fact, else fact equal to n into factorial of n minus 1, return fact. Factorial of 1 is 1. Thank you. This is end of my presentation, and I hope you gain some knowledge regarding recursive function and different types of functions like user defined functions and how to use recursive function in C programming language.